Hello, in this video I'm going to show you how to model the cylinder head for the Wighton gas engine. This is the cylinder head, the material plain carbon steel, units are inches, pounds, and seconds, drafting standard is ANSI. What I've done is drawn a 3/4 inch square on the top plane, added my plus and minus tolerance, and I'm going to extrude this to a thickness of 154 thousandths. So 0.154. Okay, and now I'm going to create that step. It's a circular step that happens, I guess this would be the bottom. So I'm going to go ahead and draw a 0.6 inch diameter circle right on the bottom. And I'm going to cut that down into the part, a shallow amount. But the way it's dimensioned on the print is it's 144 thousandths from this cut surface to the back of the part. So in this instance, I'm going to use, instead of blind or mid-plane or up to surface, I want to choose offset from surface. So I went to extrude cut. I'm going to choose offset from surface, and I'm going to choose the surface I want to offset from. So here's my sketch on the front, but I'm offsetting from the back of the part at a distance of 144 thousandths. So it's going to remove all of that material, leaving me 144 thousandths, okay? But I don't want the inside of this circle to be removed. I want the outside to remove, so I'm going to hit reverse direction, actually reverse offset, flip side to cut, third time's the charm, and I'm good. Let me back up and kind of say what I just said again. I'm sketching on the bottom of the part, okay? A 600 thousandths diameter circle. I'm going to use extrude cut to take this sketch and cut it into the part, but I want the outside of it to be cut. So I'm going to hit offset from surface, 144 thousandths, and I want flip side to cut. What that's going to do is it's taking my circle, or in this case everything outside of the circle it's cutting, and it's leaving me 144 thousandths left. File, save. Next, I'm going to create that gland ring groove, probably for an O-ring, by sketching a couple of circles. So I'm going to sketch those circles on this shallow surface. I'm going to use convert entities to convert the circle that's already there, and then draw another circle over that and dimension it to the 600 thousandths that's in the book, which means I made a mistake previously. So let's back up a second. This diameter is not 600 thousandths. It's 0.438. There we go. And this is 0.6. Perfect. And that cut is 0.047. And it looks like the cut is coming from the bottom of the part, not from this surface. So a couple of ways to fix this. I can edit my sketch plane. So instead of sketching on this surface, I should have sketched on this surface. But all of these mistakes, easy to fix, and I'm glad you're watching them. So I'm editing the sketch plane, and this was the surface I should have chosen. And now my cut is cutting from the correct depth. Okay, file, save. Now I'm going to go ahead and add the tapped hole in the center, and this was the one design change that we did. We changed it from a 1/4 inch 32 UNF to an M10 metric thread. So I want to make sure that straight tap is selected. I'm going to switch over to ANSI metric tapped hole, and I'm going to choose M10 by 1 from the list. And I want to go through all. My position is simple. It's right in the center. File, save. Now we're going to add the 4 mounting holes using Hole Wizard. I'm going to switch over to simple hole. We want ANSI inch. We want number drill sizes, and I believe it was number 44 from the list. If you hit show decimal values, it'll show you yes, we're creating a 0.086 inch hole. Our end condition is through all. I'm going to go ahead and put this center point rectangle. Actually, I'll use a corner point rectangle. Make sure it's for construction. Add my dimensions. And place a point at the corner of each one. So there is the cylinder head. Isometric view, regenerate, make sure you have no negative signs. File, save, and move on to the next part.